Today's topic is about AS chemistry carbonyl compounds. Now, what are carbonyl compounds? They are basically two. One are aldehydes and the other ones are ketones. First of all, how they can be prepared? They can be prepared by the oxidation. Number one, oxidation of primary and secondary alcohol. That's the first thing first. Now, what oxidizing agents are going to be used? It will be potassium dichromate and potassium magnate. In the it has to be acidified. And when you say acidified, means acidified with dilute sulfuric acid. The color change will be the potassium bichromate will going to change from orange to green, and potassium permanganate will going to change from purple to colorless. The change in oxidation numbers are chromium plus 3 and manganese plus 2, plus 7, plus 6. Synthesis of aldehydes. Now, how the synthesis of aldehyde is possible? So, what we do is that we take a solution over here, and on heating, since aldehyde is a low boiling point, so it will distill off, it will move ahead. Uh, and then condenses through the Liebig condenser, and then it will be cooled down. It will be taken off or separated as a distillate, warm primary alcohol, and slowly added to oxidizing agent. That's how we do it. I repeat, warm primary alcohol and added into the oxidizing agent. So by reflex and condensation, we get what? We get aldehyde. Another way through which we can explain is this, that ethanol reacting with oxygen and in the presence of heat gives us what? Ethanol. Means alcohol is changing into what? Alcohol is changing into aldehyde. Similarly, we have to produce ketones. How is that possible? Ketone can be produced simply or can be synthesized simply if we take propane 2-ol, which is a secondary alcohol. Now, what is the meaning of secondary alcohol? The OH group is attached to that carbon, which is attached to further two carbons. So propane 2-ol reacting with oxygen and changing into what? Changing into propanone. Or we can say propane 2-on. That's another way of saying it. Reactions of aldehyde plus ketones. Now, reactions are number one, reduction. And in reduction, what agents we are using? We are using reducing agents like NABH4, LaLH4. Now, NABH4 is sodium tetrahydroborate, and LaLH4 is lithium aluminum hydride. If you want to remember the names, you can, of course. So ethanol reacting with hydrogen, giving us what? Giving us primary alcohol as the end. And as far as propanone is concerned, or propane 2-on is concerned, see if CHO is attached, this is called ethanol. This is giving me what? Primary alcohol, right? It is breaking this oxygen and giving me primary alcohol. If we are taking propane 2-on or propanone, this is giving me what? This is giving me secondary alcohol and propane 2-ol. Now, nucleophilic addition with HCl. Cyanide has a negative charge and it acts as a what? It acts as a nucleophile and add across the carbon oxygen single covalent bond. KCN, potassium cyanide, will act as a catalyst and heat to produce hydroxynitriles. I repeat, KCN is what? Will act as a catalyst and heat to produce hydroxynitrile. So let's suppose you have ethanol. This ethanol is going to react with HCN. If we heat and KCN will act as a catalyst. So what happens? What I'm getting as a result, I'm getting 2-hydroxypropane nitrile. This carbon is breaking one bond with oxygen, and this one bond is getting attached with hydroxide, and the other hydroxyl compound, and the other one is carbon and nitrogen, which is cyanide, and changing into what? 2-hydroxypropane. So if I'll be using propanol, what will be the product? If I'll be using butanol, then what will the product be? Try these equations. If I'm reacting propanone with HCN, so what I'm getting in return? I'm getting in return 2-methyl 2-hydroxyl propane nitride. So this CH3, this will come with the second carbon, and this carbon will attach over here, and two functional groups are attached, and it gives me 2 methyl 2-hydroxypropane nitride. So this is how ketone is reacting to it. So aldehyde, primary alcohol, ketone when it means secondary alcohol at the end of the day, and vice versa is the scenario at the time of production. When it comes to reaction mechanism, what basically the thing is, carbonyl compounds are polarized. What is the meaning of polarized? Polarized means, see, when we say carbonyl compounds, we talk about what? We talk about carbon and the oxygen which is attached to it. No matter which carbonyl compound you're talking about, carbon and oxygen will definitely going to be attached to it. And there is a polarity. What is the polarity? Polarity is that it has a partial positive charge, it has a partial negative charge. Now the cyanide ion that is coming here, the cyanide ion that is coming, it is a nucleophile. Nucleophile means it has a negative charge. When it has a negative charge, so this negative charge will going to be attracted by the positive carbon, and hence the cyanide will going to be attached with the um, carbon of the carbonyl compound. This is the explanation is. I repeat, carbonyl compounds are polarized. Polarized means partial positive. Why it is partial positive? Because it is less electronegative. Partial negative because it is more electronegative. And cyanide is attached to this carbon. Why? Because obviously cyanide is a nucleophile. It has a negative charge. It will be attracted by the positive charge or oppositely charged just attract each other. Now, here's the mechanism. See, this was cyanide, and this cyanide is a negative charge that is attracted with this carbon. Carbon will break the bond with oxygen as another negative electrophile or a nucleophile or a negative charge element is coming to it. So, when the bond will be broken, now this oxygen here, this oxygen is over here, is in a negative charge. There's a hydrogen over here, which is this one. Then there's a CH3, which is this one. And then there's cyanide ion attached. This is a very reactive intermediate. Now, this cyanide has come from where? This cyanide has come from potassium cyanide. As we have discussed earlier, that two things we will be using when we are doing the reaction, and what those two things will were potassium cyanide and hydrogen cyanide. I forgot where I have mentioned, but I mentioned it somewhere. So this cyanide that came first was from potassium cyanide, and then the hydrogens from hydrogen cyanide, this hydrogen we're going to attracted by this oxygen, which is there in the intermediate, this oxygen. And this will be the end product. This is a mechanism. So this one is step number 2. So cyanide is a nucleophile, and it has a negative charge. Why it has a negative charge? Well, it's broke. We got two reagents. One was hydrogen cyanide and KC and potassium cyanide. Why? Because this one is acting as a catalyst. It will first give cyanide ion, and then this one gives the hydrogen ion, and this cyanide, which will be left behind, again react with potassium, and catalyst will be resumed unchanged. This is what we call catalyst. They are resumed unchanged. If we have to do the testing of carbonyl, which is really important for that, the reagent which we're going to use is 2,4-DNPH, which is dinitrophenyl hydrogen. It is a reagent which detects the presence of carbonyl compound. How is that? First of all, condensation reaction. It is a type of reaction in which two molecules join together and a small molecule, HCl or H2O, is eliminated. That's what we call condensation polymerization. Any condensation reaction which we do, this is how does it happens. Now, aldehyde and ketones, they undergo condensation reaction. When they undergo condensation reaction with 2,4-DNPH, product formed when 2,4-DNPH is also added to a solution that contains an aldehyde and ketone. So what we get? We get deep orange precipitates. This is how we identify. And that can purified by recrystallization. This is what? This is the structure of 2,4-DNPH. Now, what will happen? We have taken 2,4-DNPH, and then we have this is 2,4-DNPH, and this one is propanone, right? So H2 from DN4-DNPH and O, they will be eliminated as H2O. This nitrogen will be attached with this carbon with the three bonds. So as a result, what I'm getting a deep orange precipitates. Hmm. So if I get a deep orange precipitates, that means that the product has been formed and the presence of a ketone is justified. Now, Fehling solution, it is an alkaline solution containing copper 2 ion. It acts as an oxidizing agent. So what happens on warming with aldehyde? Aldehyde is oxidized to what? To a carboxylic acid, and copper ion is reduced to copper plus 2 ion is reduced to copper. So what did I say? I said carboxylic acid will neutralize carboxylate ion from salt, and a positive metal ion will attach to it. From a clear blue solution, what I'll be getting a red precipitate, a PAQ color kind of. But this is only the case of aldehyde. What is the case that when we are warming aldehyde? Number one, it is oxidized to a carboxylic acid, and the copper 2 ion will be changed into copper plus. From a clear blue, we get a red precipitate of copper 2 oxide, and then hence the presence of the aldehydes can be confirmed. Also, we need to bear in mind that ketones cannot be oxidized at all. Then comes the Dolan's reagent. How Dolan's reagent will help to identify the presence of the carbonyl. It is an aqueous solution itself first, alkaline solution of silver nitrate in excess ammonia solution. It is also called ammoniacal silver nitrate solution. It will be warm with aldehyde and it will give us what? It will give us a carboxylic acid. Ag plus Ag, a silver atoms form a silver mirror on the inside of the tube. That is why this is the reason they are known as ammoniacal silver nitrate. As far as ketones are concerned, ketones cannot be oxidized. That's it of carbonyl compounds. There is one thing which is included in carbonyl compounds, that is iodoform reaction, but it's the same that we have studied in hydroxy compounds. So you can always refer back and see. The essence of that is that ethanol, aldehyde will be undergo halogenation first and then hydrolysis, and at the end we will get dry iodomethane, which is yellow precipitate. Thank you.